Welcome to session 2 of Foundations of Global Health. In this session, we're going to talk about the global burden of disease and specifically about demographic shifts and epidemiological transitions. First, we're going to basically briefly just talk about the definition of health. In session 1, we basically covered the three components of health and how health was defined. Health really encompassed individual level factors as depicted by this picture, social and community factors, and basically general social, economic, cultural, and environmental conditions. And those qualifications were needed to meet health. And remember, we said that health was not just the absence of disease, but also these factors were important. In the global health community, we face four major challenges: the challenge of urbanization and climate change. These are very significant challenges, which we will discuss in another session. For this session, we are going to discuss demographic shifts and epidemiological shifts. So let's first discuss demographic shifts. Demographic shifts can be also called demographic transitions, and it's basically the demographic transitions or transitions in vital rates of populations, which can be called regional or national transitions from a pattern of high rates of fertility from death or mortality to one of low rates of fertility or mortality. And then you also have epidemiological shifts or transitions, which is in part due to mortality declines and transition from one state of disease to another state of disease. In this case, you transition from mostly communicable diseases to non communicable diseases. So, what is globalization? So, globalization basically, as defined, is the process of change that affects human interactions. And this change affects us across a range of spheres. Some of the spheres listed here include economic, political, social, cultural, technological, etc., etc., etc. And this change is globalizing, and it concurrently with great scale, pace, and intensity. The boundaries are in the dimensions of globe, and in the globalizational context, we can think of it as it's being spatial. We can experience it or perceive it within the physical space or territory. It's temporal in how we perceive and experience it in time. It's cognitive in how we think about ourselves and the world around us. It's also important that when we think about globalization and global health, that we have some common reference points or common terms that we define these things. So, for example, DALYs, or what we would say here, are disability adjusted life years. And DALYs are simply the sum of years of potential life loss due to premature mortality and years of productive life loss due to disability. So that can be summed up simply that when a person has a disease that causes disability, what is the number of what is the number of productive life that is lost? So if a person has a stroke and they are disabled from that stroke, what is the number of reproductive life lost from that stroke? The next term is Human Development Index, or HDI. It is simply a statistic developed and compiled by the United Nations to measure the various countries' levels of social and economic development. And the last that we'll talk about is GDP, which I think many of you have heard before. And that is the gross domestic product. It is simply defined as the total monetary or market value of all the finished goods and services produced within a country's borders in a specific time period. When we think about globalization and epidemiological transition, we need to think about age and how that age affects our population. So in 2013, the United Nations Department of Economic and Social Affairs Population Division came out with this publication. And that publication on aging tells us that the proportion of the world's population aged 60 years or over will increase slowly between 1950 and now, from 8 to 12%. But for the next 4 decades, will increase rapidly and expected to reach 21% by 2050. And in fact, if we look at this, we see the world is depicted here by this curve, this red curve. More developed nations are depicted here by this orange curve. Less developed regions here by this orange-ish curve, and this yellow curve is less developed countries. So overall, it shows that we have had an increase in life expectancy because the number of individuals over 60 are increasing in terms of our global population, which is good. So overall, our population around the globe are starting to increase. But how has that happened over the past decades? What does that mean for the population of different countries? And what does that mean for the future? Those are the questions that we need to ask. And what are the answers we come up with will be quite interesting. So we cannot talk about demographic or epidemiological transitions without talking about population pyramids. Population pyramids are something that are developed by demographers to look at the overall structure of the population, usually at a country level. So here are population pyramids for one particular country, sourced based on the UN, and they're based on their projections for a country based on 3 different time periods: 1970, 2015, and 2060. First thing about population pyramids is they're usually stratified based on sex. Females on one side, as you can see, males on one side. Then they're stratified by age, and you can see the different layers. So they're usually stratified by people, by individuals that are usually pre-reproductive age. So as you can see, this dotted line are individuals that are age 15 years or less. They're usually considered pre-reproductive. And then these individuals are usually reproductive age, and then anybody above 45 are post-reproductive, and then 65 and above are usually retirement age or so. And then for this country, there's 1970, and then 2015, and then of course 2060. And they give you a snapshot of how the country will look like in 2060. Of course, we're in 2021, etc., etc. But these are very informative. And in fact, on the next slide, I'm going to show a TED video of what it means, what a population pyramid can tell you in terms of the demographic makeup of a country, in terms of reproduction and in terms of a whole lot of other important factors. And it compares population pyramids amongst different countries. So it's in fact a very informative video, and it tells you a lot of information about population pyramids. And then we're going to go on and talk about population pyramids about other countries in the further slides. So this is going to be a very interesting exercise.
Russia, with the largest territory in the world, has roughly the same total population as Nigeria, a country 1/16 its size. But this similarity won't last long. One of the populations is rapidly growing, while the other is slowly declining. What can this tell us about the two countries? Population statistics are some of the most important data social scientists and policy experts have to work with. But understanding a country's situation and making accurate predictions requires knowing not just the total size of the population, but its internal characteristics, such as age and gender distribution. So how can we keep track of all that data in a way that makes it easy to comprehend? Complex data is more easily interpreted through visualization, and one of the ways that demographers represent the internal distribution of a population is the population pyramid. Here, the data is divided by gender, with females on one side and males on the other. The population numbers are shown for each 5-year age interval, starting from 0 to 4 and continuing up to 100 and up. These intervals are grouped together into pre-reproductive, 0 to 14, reproductive, 15 to 44, and post-reproductive years, 45 and up. Such a population pyramid can be a powerful predictor of future population trends. For example, Rwanda's population pyramid shows it to be a fast-growing country. With most of the population being in the youngest age groups at the bottom of the pyramid, the number will grow rapidly in the coming years. As today's children reach their reproductive years and have children of their own, the total population is almost certain to double within the next few decades. For our second example, let's look at Canada, where most of the population is clustered around the middle of the graph. Because there are less people in the pre-reproductive age groups than there are in the reproductive ones, the population will grow more slowly as the number of people reaching their reproductive years decreases. Finally, let's look at Japan. Because the majority of its population is in its post-reproductive years, and the number of people is smaller at each younger interval, this means that at current rates of reproduction, the population will begin to decline as fewer and fewer people reach reproductive age. Comparing these three population pyramids side by side shows us three different stages in the demographic transition as a country moves from a pre-industrial society to one with an industrial or post-industrial economy. Countries that have only recently begun the process of industrialization typically see an increase in life expectancy and a fall in child mortality rates as a result of improvements in medicine, sanitation, and food supply, while birth rates remain constant, leading to a population boom. Developing countries that are farther along in the industrialization process begin to see a fall in birth rates due to factors such as increased education and opportunities for women outside of childrearing, and a move from rural to urban living that makes having large families less economically advantageous. Finally, countries in advanced stages of industrialization reach a point where both birth and death rates are low, and the population remains stable or even begins to decline. Now let's take a look at the projected population pyramids for the same three countries in 2050. What do these tell us about the expected changes in each country's population? And what kinds of factors can alter the shape of these future pyramids? A population pyramid can be useful not only as a predictor of a country's future, but as a record of its past. Russia's population pyramid still bears the scars of World War II, which explains both the fewer numbers of elderly men compared to elderly women and the relatively sudden population increase as soldiers returned from the war and normal life resumed. China's population pyramid reflects the establishment of the one-child policy 35 years before, which prevented a population boom such as that of Rwanda, but also led to sex-selective abortions, resulting in more male children than female children. Finally, the pyramid for the United States shows the baby boom that followed World War II. As you can see, population pyramids tell us far more about a country than just a set of numbers. by showing both where it's been and where it's headed within a single image. And in today's increasingly interconnected world, facing issues such as food shortages, ecological threats, and economic disparities, it is increasingly important for both scientists and policymakers to have a rich and complex understanding of populations and the factors affecting them.
The TED video had a very illuminating discussion on the population pyramid of Japan. We can see two population pyramids here for Japan from 1950 and one from 2015. As we can see, from 1950, the population pyramid for Japan shows that the majority of the population were either in the pre-reproductive phase or in the reproductive phase. However, as the population has aged, the majority of the population has shifted from the pre-reproductive or reproductive phase to where the majority of the population now are actually in the retirement age or in this particular phase. So this can be sort of, as you can envision it, as an upside down top. So this is more reminiscent of a more industrialized country, as has been indicated by the TED Talk video. This has been a result of there being more opportunities for women, in which there are career advancements, in which women have more duties outside of just child rearing. In the next other populations that we're going to discuss, we'll look at their populations and talk about their population pyramids. When we look at the population pyramid for Mexico, we see that individuals within the pre-reproductive phase of their life cycle are significant in this particular population. And when we see that individuals within the reproductive phase of their life cycle, as indicated here, are still significant. So we see that this particular population has room for growth. This is indicative of a population that's still expanding. And in fact, we see that individuals that are in their post-reproductive phase are not as well represented within this particular population. So this population has room for expansion and is indicative of a population that is within a lower or middle income country. So it has room for expansion and room for growth. So the last population pyramid we're going to talk about is Russia. In terms of the population pyramid, we're going to really briefly cover Russia. And in fact, the TED Talk did a very remarkable job of highlighting the fact that there was a significant issue in terms of the number of males in Russia that were affected by World War II. So there's a decrease in the male population, which can be seen here from World War II, which is still seen in Russia, which is impacted by what you see in the population pyramid. And in fact, there's an interesting correlation between what you see in Russia right now, reflected in at least this 2016 population pyramid, which still exists today, and a greater conversation going on what's going on in Eastern Europe. The next video that I'm going to show after this is one of a conversation that occurred amongst several individuals that was hosted by Al Jazeera in 2020, which they were talking about depopulation occurring across many countries in Eastern Europe, in which there's an actual decrease in population in many Eastern Europe countries. And this is a fascinating story in which we've talked about population pyramids, in which there are some countries in which there's actually not a lot of individuals of reproductive age in those countries, and there are a lot older individuals. So the pyramid actually looks like an upside down top. Think of it as the Japanese population pyramid, and this occurring in other parts of Eastern Europe. So the Al Jazeera presentation or video that's going to be on the next slide talks about that phenomena happening in other Eastern European countries.
Welcome to the stream. I'm Femi OK. The UN says the world's population will grow by a quarter between now and 2050. Yet the populations of many European countries are plummeting. Why is that? And what can be done to tackle it? Send your thoughts through Twitter and YouTube. The world's population is forecast to grow by 2 billion people in the next 3 decades, with some of the largest rises expected in countries such as India, the United States and the Democratic Republic of Congo. But many countries from the Balkans to the Baltic face severe depopulation. Of the 20 countries with the biggest expected drops in population, 14 are in Eastern or Central Europe. Observers say that the region is now facing a demographic emergency as thousands of young people leave their hometowns for new lives in other parts of the world. For more on this, we are joined from Sofia by Hristo Boyadjiev. He is founder of Tuktam, an organisation that helps Bulgarians find opportunities at home after returning from abroad. And Alida Vracic is a political scientist and currently a fellow at the Vienna-based Institute for Human Sciences. She joins us from Bosnia and Herzegovina's capital, Sarajevo. Hristo, Bulgaria's population has dropped quite consistently. What does it feel like as a Bulgarian to be in Bulgaria and to have fewer people? Do you even notice it, Hristo?
Actually, don't. I think we should distinguish between living in Sofia, the capital, versus living out somewhere in Bulgaria. In Sofia, it doesn't feel like it. Sofia is a very vibrant city. If anything else, the population has drastically increased over the past 20, 30 years, and we are probably 2 million now, which is, I guess, a third of the country. When you go outside of Sofia, though, especially in certain areas, you do feel that, fewer young people, less job opportunities. So there is a sense of sort of Bulgaria 2 speeds.
Alida, there are so many reasons why the population has dropped in Eastern Europe. Talk to us about birth rates. Do people just not want to have babies anymore?
I'm afraid it's not that simple, to be honest. This story is completely not one-dimensional. Of course, there are socioeconomic reasons for people not wanting to have more children and people actually emigrating from the country. But there are also other reasons, like stagnation, feeling of impotence, feeling that your voice doesn't mean much. And you have entire generations being born and growing up with the sense that they will become part of this better Europe, which is western part of Europe. But EU enlargement and policies around EU enlargement simply prevent those kind of events and dynamics. This is why people feel that they have to do something themselves, and this is why they decide to vote with their feet, and this is why they leave. As for the low fertility rates, it's really a complex issue, and many countries did try to battle this, some successfully and some not so successfully. I don't think one policy in isolation actually matters. It has to be a complex structure. It has to be this discussion about immigration as well, attracting people back. So not only diaspora, but other people from other places back into your country where there are opportunities being created. So it's a very, very complex issue, and often it's being sort of it's being sort of presented as one, depopulation and emigration, while these are completely unrelated issues in a way.
We're joined now by Tim Judah. He's a Balkans correspondent at The Economist, and he joins us from the Italian city of Genoa. Tim, it's great to have you here. I'm just looking at some of the work that you've done, and you've looked into the Balkans in particular, a region in critical demographic decline. That word critical, how serious is it, Tim?
Well, it's extremely serious. If you look at some of the projections for up to 2050, and you go back to 1989, so the period of the end of communism, by 2050, Bulgaria is projected to lose 39% of its population, Romania 30%, Serbia 24%, Bosnia and Herzegovina 29%. and so on.
Yeah.
So it's a very serious problem. And it is not a simple problem, as Alida said, but it's basically three issues which are combined. It's emigration, low birth rates, and the fact that there's no immigration. You put all those three together, and that's what you get. You get a region in critical demographic decline.
Sure. We are on YouTube right now, so people are following on YouTube. David jumped on super early today. Eastern Europe, especially, he says, has a history of changing and migrating populations. Changing demographics and population is not a process that can be stopped or resisted. Risto, you went abroad for a while, you studied abroad, and then you came back. This idea of trying to stop people from leaving, is that even realistic?
I wouldn't call it stop people from leaving. I'm actually a firm believer of giving people the opportunity to better themselves, find opportunities, and actually be engaged wherever they are in the world. So our mission at Tuktam, which by the way is a wordplay on here and there in Bulgarian, is all about creating a global community of people who, regardless of where they are, they're informed, engaged, active in what's going on in Bulgaria. So I think that's the way to move forward, rather than tell people for everybody to come back necessarily. It's about, okay, how can you help even if you are not located in Bulgaria?
Absolutely. May I just add to this?
Please, Alida, go ahead.
It's absolutely, I mean, one way to think about this is that there is no way to actually prevent this trend, because departures will continue happening. And there was a myth for some time that once you become part of the European Union, this will stop. Just looking at the example of Croatia, one can see that this doesn't make sense, because Croatia has lost like 200,000 people since it entered the European Union in 2013. What are the policy measures that actually would make sense and be meaningful is to encourage people to get some experience and to actually go abroad, but then offer possibilities back home that will attract them back. So by inviting them back, you also attract other talent. So I think it would be extremely wrong message to be sent that this trend can be just stopped and anyone should actually even attempt to stop it.
I'd just like to add there that it's very clear that where there are sectors where there are opportunities emerge and people are paid decently, they get good conditions, then people start to go back. Let's take a skilled sector, the tech sector. I was last week in Serbia reporting a story about the tech sector there, and it's absolutely fascinating. They have no problems retaining people because they pay people well, and life is comparatively cheap in Serbia. So skilled people in that sector are staying, and not only that. Many of the bosses in that sector, people who are running either foreign companies based in Serbia or they're running Serbian startups, many of them absolutely, just like has been described, have been abroad and come back.
It's almost as if you read my mind, Tim. I want to play a little clip from Zoya Kucic, who talks about the reasons why people have been leaving Eastern Europe, but also one reason why they might want to come back, and that's tech. Have a listen.
In terms of brain drain, in Serbia, we notice two main reasons that motivate people to leave. One is general environment due to bad rule of law, corruption, and other things that influence it. And the other is financial reason, people not being able to find job or earn enough money. When we talk about the tech sector, this second reason doesn't really apply because people earn 3 to 5 times average salary in the country, which enables them to have a good lifestyle. And what we also notice in tech sector more and more is that we have an influx of people and specialists and professionals from Western Europe, US, and other parts of the world, which are coming to work for successful Serbian startups or international R&D centers.
Who say you are looking for that positive? You're looking for the
data from the United Nations, Global Burden of Disease, and other sources shows us that over the past 50 years or so, there has been a significant increase in the life expectancy of people around the globe. From this 2017 data, what we can see is data in the dark blue to the light blue, we can see significant increases in healthy life expectancy around the globe. Even data in the orange to yellow areas, we can see that there are increases in life expectancy. Now, countries like Japan, even though 2017 they had an increase in the high 70s, in 2021, data shows that they have increased their life expectancy from the mid 70s all the way to the 80s, to the lower 80s, which is significant. So that has been an improvement. So this is significant news, important news in terms of the global burden and in terms of disease, and have shown that we've had an overall gain in terms of life expectancy. This gain has not been equally distributed, as can be shown in the map. High income countries have gained more in terms of life or healthy life expectancy compared to lower or low middle income countries. And these life expectancies will continue in terms of this. And then also recall that in terms of life expectancy, the attributable death to communicable diseases is significantly more in terms of lower middle income countries compared to higher income countries, where more people tend to die from non-communicable diseases, which we'll discuss in the next chart. When we stratify by specific disease categories, when we look at non-communicable and communicable diseases, we see that disease categories that are non-communicable diseases, these three here cluster, are continuing to increase starting from below 2005 to 2030 and are projected to increase beyond 2030. However, communicable diseases specifically are decreasing. So let's look at a few examples. So for example, in this red line right here, which represents acute respiratory infections, from 2005 has continued to decrease and will continue to decrease to 2030, and even projections will continue to decrease lower. The same for this black curve, which represents HIV, AIDS. Same for TB, which is basically this dotted curve. Same for malaria, etc. The one exception is, of course, road traffic injuries and other injuries, which are unfortunate. Perinatal diseases are also, in fact, also decreasing. When we look at these three non-communicable diseases, cancers continue to significantly increase, and will continue to increase beyond 2030. And these are measured in deaths per million. By 2030, cancers will increase to over 12 million deaths by 2030. For ischemic heart disease, based on the latest estimates, will be over 8 million, and of course strokes will be significant also. When we talk about epidemiological transitions, this is basically the crux of the argument. When we look at the data based on 3 time points, this shows epidemiological transitions: 1970, 2015, and 2030. In the 1970s, if we look at the pie chart for 3 things, in the yellow or orange, 40% made up non-communicable diseases, 7% was injuries, 53% was basically communicable diseases, which consisted of perinatal and maternal diseases. 2015, in fact, communicable diseases had decreased from 53% to 25%. In fact, what we saw was non-communicable diseases had increased from 40% to 66%, and we only saw a slight increase in injuries from 7% to 8%. That is basically the epidemiological transition, where you saw an increase from non-communicable diseases from 40% to 66%, and a decrease in communicable diseases from 53% to 25%. Again, from 2015 to 2030, what we are expecting to see is a further increase from non-communicable disease from 66% to 74%, which would make up basically 3/4 of the diseases that we see among the world population. And further, a further decrease in communicable diseases from 25% to 7%. And in fact, we'll also see a slight uptick in injuries from 8% to 9%. So we talk about communicable, non-communicable diseases. So what are these diseases that we're talking about in terms of the epidemiological disease? So we can look at the global burden of disease as one particular data set. There are other data sets that have different disease types and predict different models based on their own models, different diseases that will be more abundant depending on how they shape their models and what factors they put in. This is just one model in terms of what disease types. So in terms of this disease, this is from the WHO, World Health Organization. So they looked at diseases that were abundant in 2004 compared to what disease, based on their modeling of the disability adjusted life years, that would be at number one based on 2030. So in 2004, lower respiratory infections were number one, and they predict by 2030 that would basically be at number 6. And in fact, what they think would be number one based on their modeling would be unipolar depressive disorders. They think number 2 will be ischemic heart disease, and in fact, ischemic heart disease was at number 4 in 2004. And in fact, if we look at what was number 1 through 5 in 2004, there was the respiratory infections, diarrheal diseases, unipolar depressive disorder, ischemic heart disease, HIV/AIDS. When we look at the rankings for 2030, it's going to be depressive disorders, unipolar, of course, ischemic heart disease, traffic injuries, cerebral vascular disease, COPD. So it's going to be a significant change between 2004 and 2030. So again, this is the epidemiological transition where we go from more of an infectious disease sort of phenotype sets of diseases that we have to more of less so more of a communicable disease phenotype in terms of the world population that we're going to see. And then when we look at the top 10 causes of death, when we separate it out by sex, we see that from 2000 to 2016, and this is actually the same data, the disease rankings have not changed as far as I'm aware of. For 2020, it was ischemic heart disease from 2000 to 2016, and I believe it's still the same. Stroke, chronic obstructive pulmonary disease, lower respiratory infections for both sexes. And those are basically the diseases that I believe are still around, that are still significant. So when we look at this data, which is published from the findings of the Global Burden of Disease study from 2017, in the 1990s, the first 3 diseases was communicable disease. 2017, the first 3, 2 of the first 3 were non-communicable: stroke and ischemic heart disease, followed by neonatal diseases. For total mortality, for preventable mortality, and then, of course, by 2040, it is projected to be, of course, ischemic heart disease, stroke, and lower respiratory infections. And then, of course, of the top 10, the majority of them will be non-communicable diseases, with HIV, AIDS, and malaria not being either amongst the top 10. So that is where we're heading to in terms of these diseases. So in terms of global mortality, we believe that based on the trends that we've seen, and this is 2021, next year will be 2022. We believe that we are going to be seeing a significant transition from communicable. Well, we're already in a non-communicable transition, but we believe that even more so, we're going to see more non-communicable diseases, and by 2040, we're going to be significantly seeing more non-communicable diseases at this point, in terms of preventable mortality, in terms of that. On a final note, it is worthwhile to point out this particular study. This study was published by the Global Burden of Disease Study last year, 2020, and it highlights 87 risk factors in 204 different countries. These 87 different risk factors actually contribute to all the disease burden that we're seeing. And it actually looks at the risk factors from 1990 all the way to 2019. And it shows that there has been a difference or significant change in the risk factors in 1990 compared to the risk factors that we see in 2019. These risk factors are actually the drivers of disease in 2019, 2020, and so on. So they underlie the epidemiological shift that we see. So, for example, the first three risk factors, high systolic blood pressure, smoking, high fasting glucose, are all contributors to what we see in terms of cardiovascular disease, COPD, and diabetes. All these three actually contribute in their own way to cardiovascular disease, lung disease, etc. And those specific risk factors contribute in multiple ways to all the non-communicable diseases that we're going to see. Depending on what models you use, different diseases will be in different rank orders, but the underlying risk factors that contribute to all these specific diseases are going to be there. So it is very important to highlight these things and to understand that the risk factors remain no matter what, because those risk factors are basically attributed to behavior and certain things that we do in terms of humans. Those things are sort of, in many ways, require us to change our approach. So it is worthwhile to really look at this paper and to examine it from a global perspective around the country, around the world, in terms of thinking about at least the epidemiological shifts that are occurring globally in terms of this study.